So guys, now let us discuss the goals of this section of the course in a little more detail. So the problem statement is that given a network graph, compute the routing table of each node or L3 device in the graph, right? So we are given an input which is nothing but an input graph, and we are looking to understand the algorithm using which each L3 device or node in this graph computes the routing table which respect all the four properties which we discussed in the previous slide. So a network graph is a graph where nodes represent L3 routers and edges represents the wires connecting these L3 devices. All edges are P2P links and has a cost attached to it, right? So it's a P2P link. P2P link is a link which connects two devices end to end. And what link is not a P2P link? For example, this particular link is not a P2P link which is connecting the device A with the L2 switch. So this link is not a P2P link. A P2P link is a link which connects the two L3 devices together. This L2 switch can have more L3 devices connected to it, so it means that device A, B and C could be in the same network, right? So all these links are not P2P links. So we have made an assumption that we will going to understand the algorithm by assuming that all the links in the topology are P2P links. So edge ends have IP addresses configured and have interface name. So you can see this is an edge, or you can say it's a wire, and every end of the wire which is connected to the device has an interface name. In this case it is Ethernet 0 and it is configured with an IP address. And all nodes in the topology has a definite name. For example, the name of this node is A, then you have B and C, right? And every node in this topology have their respective loopback addresses. For example, the loopback address of the node A is this particular loopback address. Similarly, node B's loopback address is this one, and so on, right? So loopback address serves as a unique identifier of a device in the network topology. So this is the input to our algorithm which computes routing table, and the output will be the routing table of each node of the topology, right? So each node in the graph must compute the routing table, and this will be our output. And here routing table means that every node must know how to reach a given remote subnet in the graph. So here our given remote subnet is nothing but it is a loopback address of other L3 devices. So it simply means that router A must know how to reach the loopback address of the router B and the loopback address of the router C, right? So A must know that in order to forward the traffic which is destined to the IP address 192.168.0.1, it should forward the traffic out of the local interface Ethernet 0 towards the gateway IP address 10.1.1.2, right? So this information is called next hop information. So our output can be summarized as follows: that node I must be reachable to node J through shortest path in the graph for all ij's, right? That is, every device must know how to reach every other device in this topology via shortest path. So this is the problem statement of our course, and we will going to attack this problem statement in a step-by-step manner in this section.